Hello friends, I am Nalini Rajagovindan and welcome to my channel on Vaira Citadel. In my last video, we have learned what a hypothesis is and what are the various types of hypothesis and their significance in any research. And today, we will be learning what is hypothesis testing and what are all the errors that can creep in during this process of hypothesis testing and how to overcome those errors. This is a very important topic from UGC NET point of view. Stay tuned till the end. Before starting with hypothesis testing, there are certain facts which you should get into your head by any means. It goes like this. Hypothesis is an educated guess. It is a claim made by the researcher which is put to test. And after testing, the researcher is either going to reject the null hypothesis or fail to reject it. In other words, accept it. Note that it is always the null hypothesis which is put to test. After testing, the researcher will either reject it or fail to reject it. It's always failing to reject it, not accept it. But anyway, it means the same. And you cannot always prove something. For example, you say that the girls score more in +2 mathematics than boys. In this, we cannot prove this easily because we do not actually know how much more is really more. But if we state the null hypothesis as like this, there is no difference in the mathematics scores of +2 girl students and boy students. And for this, the alternate hypothesis will be that there is difference in the scores of +2 boys and girls in mathematics. And if you see any difference, we can reject the null hypothesis and fail to reject or retain the alternate hypothesis. And we can prove that the scores are different. And by doing a two-tailed test, about which we'll be discussing in a later video, we can even prove the direction of the scores. That is, who is scoring more, whether the girls are scoring more than the boys or the boys score more than the girls. So the null hypothesis is more precise and testable. Here is a set of rules which I would call as golden rules, and they have to be remembered always while doing any research or while solving any problems in hypothesis testing. What are they? It goes like this. Always read the information, given information carefully. And write, the first thing is you should write the null and alternate hypothesis correctly. They are always mathematically opposite. That means the alternate hypothesis is whatever the null hypothesis is not. So put together, when you put together the null hypothesis and the alternate hypothesis, they should include all the elements. And about this we'll be seeing later in the next slide. And it's always mu is mean. The symbol mu means it is mean. And P is proportion. And alpha is the level of significance. And C denotes the level of confidence. And both alpha, level of significance, and C, level of confidence, should add up to 1. Alpha and C add up to 1. So they are always essentially the same. They mean the same. For example, when we say the level of confidence C equals 95% or 0.95, the level of significance or alpha is 5% or 0.05. Another example, when we say the level of confidence is 99% or 0.99, the level of significance, that is alpha, is 1% or 0.01. So usually we use these two levels of significance. That is alpha level, that is 0.01 or 0.05. But sometimes if the situation warrants, the researcher may have the higher level of significance or lower level, which we see it in the example. So here is an example of null hypothesis and alternate hypothesis, where the null hypothesis says the temperature equals or below 98.6 degree Celsius, and the alternate hypothesis says the temperature is above 98.6 degree Fahrenheit. So see this example and see that it is all about the body temperature. And this example we are going to use in a problem solving session, a practice session given in the next video, where we'll be discussing in detail how to solve the hypothesis testing problems and what is type 1 error and what is type 2 error with question and answer sessions. So now just you see what is the null hypothesis and what is an alternate hypothesis, and they are mathematically opposite. That is, here, what does it mean mathematically opposite? That is, null hypothesis includes the temperature 98.6 degree Fahrenheit and all the temperature below it. So 98.6 is the normal human being's body temperature. And the null hypothesis includes the normal body temperature 98.6 and below it. Sometimes we call hypothermia, And the alternate hypothesis includes all temperature above 98.6 degree. So you see that alternate hypothesis includes whatever the null hypothesis is not including. So they are mathematically opposite, and put together, if you put together both null hypothesis and the alternate hypothesis, it includes all the temperature. Null hypothesis includes 98.6 and below, and the alternate hypothesis includes any temperature above 98.6 degrees. So that is what we mean when we say that the null hypothesis and alternate hypothesis are mathematically opposite, and put together they encompass all the elements of body temperature. Here the example is body temperature. I hope you got it. Hypothesis testing, what we are really doing is we are checking whether our claim, whether our guess is correct or not. So our claim is put to test. And there are 4 possibilities here. And these 4 possibilities are shown in the table here. In the rows whose heading is decision arrived, we have 2 possibilities. That is, when we take a decision, we either reject the null hypothesis or fail to reject it, which also means we are accepting it. Failing to reject is accepting it. In the column heading, we have in reality what the null hypothesis. We may take any decision, but what is the reality? So that is given in the column side. So the heading is in reality null hypothesis, and we have 2 possibility, whether it could be true or it could be false. When combining the rows and the columns together, you have to combine them, the corresponding row with the corresponding column, and put the result in the box. So we are getting 4 possible combinations. What are they? The first combination is you fail to reject the null hypothesis when it is true. That means you are accepting the null hypothesis when it is true. So accepting when it is true is a correct decision. And the second possibility is you reject the null hypothesis when it is false. So you are rejecting it when it is false, which is also a correct decision. So the second possibility is also a correct decision. And now comes the errors. What are they? You reject the null hypothesis when it is true, which is of course a wrong decision. You are rejecting the null hypothesis when it is true. So it is a wrong decision. And this type of error is called alpha error or type 1 error. This is the first type of error. And what is the second type of error? Type 2 error or beta error. And here what we are doing is we are failing to reject the null hypothesis when it is false. So when it is false, what you should do? You should reject it. But we are failing to reject the null hypothesis when it is false. Again, committing a mistake, error. And this error is called beta error or type 2 error. Now, having learnt what are the type 1 errors and what are type 2 errors, now we should know how to avoid these errors. We can do this by either of one method. One way to avoid these errors, type 1 error or type 2 error, is to select a large sample size so that we will not have any chance error or sampling error. That is one way of avoiding this type 1 error, type 2 error. Another way, which is in case we are not able to choose very large sample, then we can do it by adjusting the level of significance. Now you should know what is level of significance. I'll tell you this with the help of a simple example. Suppose we have 100 beads, colored beads, and out of which 95 are white and 5 are black. Now suppose I randomly pick a bead, one bead I am picking. Remember, it is the choice is random, not with any preference. I'm not going to choose the color I like or because it is white or it's not. No. I'm going to choose one bead out of this 100 beads randomly, probably. I may even close my eyes and pick up one bead. In that case, I can be 95% confident that the bead is going to be white and not black. If I say it in other words, my level of confidence will be as high as 95% that I'm not going to get a black bead. This is called 95% confidence limit or 5% level of significance. Because 100 minus 95, 5. So if my confidence level is 95%, my level of significance will be 5%. Or you can even simply say the level of significance is 0.05. It is 5%. And similarly, if my confidence level is 99%, when it will be 99%? When there are 99 beads, white beads, and only one black bead is there, then my level of confidence, I can fix it as 99% confidence limit, and my level of significance as 0.01 level of confidence that I'm going to get white beads. So this is called the level of significance. So by adjusting the level of significance, the researcher can avoid the type 1 error or the type 2 error, which we will be discussing it in the next video with a suitable example. You will know it much better. And now, never forget this. One more golden rule in hypothesis testing. That is, lower values of alpha reduces the probability of type 1 error and increases the probability of type 2 error. Conversely, higher values of alpha increases the probability of type 1 error but reduces the probability of type 2 error. You should never forget this rule. So the researcher has to negotiate in choosing the alpha value before testing the hypothesis, not after the test. Before testing the hypothesis, he has to determine his alpha value, whether it is 5% or 1%, keeping in mind which type of error he wants to minimize. And please remember, this varies from case to case and from study to study. Type 1 error and type 2 errors vary for each case depending on your null hypothesis and alternate hypothesis. In some cases, type 1 error will be more dangerous and serious than type 2 errors, and in some studies it will be the other way around. So the researcher has to be very careful and choose the level of significance, alpha level, before testing the hypothesis. Hi friends. So now you know how to write null hypothesis and alternate hypothesis correctly, and what is type 1 error and what is type 2 error in hypothesis testing, and what are the significance of these errors and how to avoid them. In my next video, you are going to solve a problem in hypothesis testing, and don't worry, the solution will be given and you can always learn. Until then, signing off, Nalini Rajagovindan from Vaira Citadel. Thank you.